Alright, so we are going to look at, I think it's the last problem in the 19110 notes. We hadn't quite wrapped up 3B yet, and we'll have to come back to that at another time. But example 4, sketch a picture of a rational function with the following property. Alright, so here we go. What properties do we have? F of x has a whole at x equals 1. I don't know where it is, but let's say it's here at 1, 4. Alright, there's a whole at x equals 1. As x approaches 4 from the left, the curve increases without bound. Now, I automatically do that asymptote in there. Do you understand why? Because if the curve is increasing without bound, as it approaches a value, that means there's an asymptote there. You're shooting up or down. In this case, we're shooting up. All right? As x approaches 4 from the right, it decreases without bound. Now, it doesn't say anything else, so I'm just going to go ahead and imagine there might be a horizontal asymptote in there, and it might look like that. That would be an example, not the only example, but that would be an example of that. Would you agree with that? All right, let's look at the next one. We have a hole. Oh, we have 2 holes. We have one at -2 and 3. Okay. And we have an asymptote at -1, vertical. And on both sides, I'm decreasing. So I'm going down and down. So where were those holes? So -2, there's like a hole here. Does that look okay? And then there's also a hole at 3. I could actually put it here if I wanted. I put it where I want. And I could have an asymptote here maybe. What do you think about that? Okay? Alright. So that's finished up. That homework will be due on Tuesday, the 19110 homework. Now I want you to look at that 17 homework that I just returned for most of you. Some of you may have gotten it back another day if you turned it in earlier. But let's look at your 17 homework because I want to make sure that we talk about these slant asymptotes. So, almost all of you recognize 1.7 homework, number 1C. Almost all of you recognize this was going to have a slant asymptote. Why? Tell me how you knew that. Exactly. Power of the numerator is 1 bigger. That automatically means we're going to have some kind of linear asymptote. And almost all of you delightfully said, I got a slant asymptote, and it's going to be something like y equals x. Because when you compared this right here, which is exactly what you should have done, it's y equals x. Now, what that, at this point, all you have figured out is that whatever the slant asymptote is, it's parallel to this. It has a slope of 1. But there are lots and lots of lines that have a slope of 1. We want to find the particular one. To find the actual slant asymptote, you literally do this division. Now, do you remember doing synthetic division last year? That is by far quicker and easier than long division, although you could do it long division. The way synthetic division works is you write down these numbers. So I write down 1, a -9, about that? And out here in a little box, I use a box, not everybody does. I put a little box out here, and I put 3. If this had been x plus 3, I would put negative 3. Then I draw a little line across here, leaving some space, because I'm going to fill this in a minute. And I drop this 1 straight down. This looking familiar? 3 times 1 is 3. Add. 3 times negative 6 is negative 18. Add. Now, do you remember what that row of stuff represents? This was x squared minus 9x plus 1. What is this now? X minus 6. And what's this guy right here? That's the remainder, right? And we don't care about that. We don't care about the remainder. Our slant asymptote is y equals x minus 6. Another one was E. Again, I'm very, very happy that almost everybody recognized this was going to be a slant asymptote. And furthermore, just like before, you recognize that it was going to be essentially y equals x. But just like over here, we have to figure out what the rest of the line is. So I'm going to do a division. Now here's a funky rule about synthetic division. You can't have a number like that right there. Okay? So I'm going to divide everything by 2. So what will be out here in my box? I'm dividing everything by 2, so out here in the box will be 1/2. If you do polynomial long division, you do not have to do this. If you want to do the long division, you can just use them as they are. But if you're going to do synthetic, I'm going to make that a 1/2. And then what do I have across the top? I have a 1, a 4, and a negative 1/2. Everybody with me? Straight down. 1/2 times 1 is 1/2. I'm going to add, so 4.5 or 9/2. And you can keep going, but remember, this doesn't matter in terms of slant asymptotes. The remainder doesn't matter. So what is the equation of my slant asymptote? Y equals x plus 9/2. If your asymptote is anything, if the difference in the powers is more than 1, then you will have to use long division. So if your asymptote's going to be a quadratic, then you're going to be, actually that's not true. That's only true if your denominator is bigger than 1. So forget that, just don't worry about it. Okay, all right, next, one more task. Go back to your notes, go to the back of the page called The Whole Truth. So it's the very next page in your notes. And we are going to graph this guy start to finish. He's kind of an easy one. We'll work our way up. But we're going to graph this from start to finish. So here we go. Any thought on what we might want to do first? Factor everything, right? So and And then what do I notice? I'm gonna have a hole in my picture where x is -4. And how will I find my y? Plug it in. So it looks like on top I get -8. Did you get 8/5? So I'm just gonna bring that over to my graph and put it on, might as well put it on there. So -4, -8/5. My removable discontinuity, my hole. Now remember, this is what you're graphing. What do you notice about that, Sylvia?
I think you put the hole in positive.
It is positive, isn't it? Yeah. Thank you. What do you notice about that? What are some other things, Charlie?
Well, there's an x minus 1 at the bottom, which means there's a vertical asymptote of 1.
Exactly, at x equals 1. So I'll sketch that in. As a non-removable discontinuity, my vertical asymptote at x equals 1. Good. What else? What's my end behavior asymptote? I heard someone say it. I thought, y equals 1. Don't I have a horizontal asymptote at y equals 1? Where does that come from? Right here, right? This is not a slant asymptote. These guys match. So it's x over x, 1. What does this tell me? What info do I get from the numerator? The 0. So I got a 0 at 4. In other words, there is one place where I cross the x-axis, and it's right there. Do I cross the y-axis? How do I tell? What do I call that point? I call that point the y-intercept. And how do I find it? Let x be 0. Where do I get it? I let x be 0. 4. Now, we have put in our picture all of this important stuff. All that stuff listed right there. The intercepts, the asymptotes, holes, it's all in there. Now, based on that, could you sketch your picture? I think you absolutely could. Now, in this exercise, they tell you in problem number 2, they tell you to plot some extra points. I don't think you need to in this one. You can always plot more points if you want them. But isn't it pretty obvious that this thing looks like this? And if you say to me, that's not very obvious to me, I will ask you this question. What happens when we have asymptotes in our picture? Don't we have to get closer to them? Isn't that what asymptotes mean? So as I go, this is a vertical asymptote. So as I go up and down the page, up and down, I have to be getting closer to this. Since this point and this point are connected, it seems like that's going to go up, right? You might say, well, could it come down? And the answer is absolutely not, because if it did come down, what would it have to do? And it can't. It can't.
If it's like, if you have like an equation of the same degree and on the top and the bottom, is it always going to be y equals 1 for the horizontal asymptote?
Well, it depends what the coefficients are. If this had been 2x minus 4, it would be y equals 2.
Gotcha. Okay.
Yeah. That was the rest of the 1.7 homework. That was that whole beginning there. All right, so I am a big believer in once you get your important stuff in there, sketch in. If you can't see what it looks like, then pick a few more points. Just plot a few random points, and that will figure it out. You'll figure it out from there. Okay?
Is so the horizontal asymptote, to find that, is that just like the nine
No, the horizontal asymptote? No, that's right here.
Oh, just the X.
That's your end behavior asymptote.
Okay. So if it was like 2x over x, it'd be 2.
Okay, now I want to have you move on to problem. So now we got a bunch of things to graph. So go to problem 3. We're gonna do one more kind of easy one, and then we'll do one that's a little more challenging. All right, so now we're gonna sketch this one. We'll come back and actually fill in all that info. But right now, let's create the graph. All right, let's see what it is. So how do you think we should start? This is problem number 3. Factor. Okay, well that's great. What do you notice though about this time? Nothing canceled, which simply means that whatever this looks like, it's not gonna have any holes. Okay, but what does it have? This tells me a time right here. What does it have? 2 vertical asymptotes. One of them is at x equals 2, and one of them is at x equals negative 2. Very good. Perfect. What else does this tell me? I have 2 zeros, x-intercepts. I have one at 1, and I have one at negative 1. Okay, so far so good? Now, do I have a horizontal asymptote? Yes, it's y equals 1. Guys, that was a lesson a while back. We compare those x's, right? And if the powers match, then your end behavior asymptote, your horizontal asymptote, is just that. I think this is everything. I mean, the important stuff. Any thoughts on what this guy looks like, Charlie?
Upside down parabola.
So right in here, we have, oh wait, I haven't done my y-intercept.
Sorry.
Yeah, no, you're right, I forgot. Let's get our y-intercept in there. What's our y-intercept? 1/4. There we go. Now, Charlie, I can see a little parabola in here. Does that make sense to everybody? But while I don't have any other points plotted, there is something over here and there's something over here. Okay? So what do you think is going on over there? I don't have any points. Could I plot some if I'm not sure? But I don't think I need to. Quinn, what do you think? I saw your hands moving back there. What do you think?
I mean, I don't know how to explain it, but like, I think the right side goes like that, and left side goes like that.
And I think Quinn is exactly right. Now, you can plot points. So if you're unclear, unsure, nervous, go and plot some points. But I want to show you something. These guys are asymptotes right here. The way we behave around asymptotes, my picture doesn't have any choice. It either looks like this, or it looks like this. Those are the only choices, because I gotta get close up to this one, and I gotta get close to that one. It can't be this option, because I can't do that, right? So therefore, it has to be that option. Same thing on the other side. See that? Yeah. All right. All right, let's take a look at number 4. This time I'm going to start with my y-intercept, so I don't forget it. What's my y-intercept? 0. All right. I can't factor, can I? All right. Am I going to have any vertical asymptotes? No, vertical asymptotes come when this is 0, and it can't be 0 with real numbers. So there's no vertical asymptotes. Do I have an x-intercept? I do, but I've already plotted it. Do I have a horizontal asymptote? I think I do. What happens, Avery, when the power on the bottom is bigger? Y equals 0. Now that's the first time we've seen that. Let's talk about this for a second. Vertical asymptotes are untouchable because vertical asymptotes arise when the denominator is 0, and you can't ever be 0. How do horizontal asymptotes happen? Horizontal asymptotes happen when we take the limit as x approaches positive and negative infinity. Remember, horizontal asymptotes are end behavior asymptotes. And this is end behavior, right? So what does this say? It's an asymptote when x is really, really big or really, really small. This is not an asymptote in the middle. It's not even really in the middle. Technically, I shouldn't even draw it in the middle because it's only an asymptote on the ends because it's a limit. So therefore, can I do anything I want to a horizontal asymptote in the middle of the picture? Yes. Do not be alarmed. They are crossed all the time. And it's perfectly okay. Don't ever cross a vertical. Okay? Oh, wait a minute. Wait a minute. What am I going to do here? I have no idea what this looks like. What do you think we ought to do? Plot point, yeah, let's see that. If I put in 1, what do I get? If I put in 1, I get 1/2. What if I put in -1? -1/2, don't I? So if I put in 2, I get 2/5. But -2 would give me -2/5. Let's put in 10. 10 would give me 10 over about 1/10. And over here would give me this. Now do you have any idea what it looks like? Very, very strange indeed. But that's what it looks like. time for one more. Let's have you and your partner, which one haven't we done? Let's have you and your partner do number 2. You and your partner do number 2.
Okay, so I rewrote it as negative x plus 1. So I think the horizontal asymptote would be negative 1. Yeah. It's the vertical, I mean the zero. It's just whatever. No, I think the horizontal is negative. Or no, vertical. X and Y.
We have
X equals 1.
for a class.
Is there a 0 and x equals 1?
We're about out of time. Did this one have a y-intercept? No, because it actually has a vertical asymptote at 0, right? Did it have an x-intercept or a 0?
Yes.
Where is it?
1.
1. Does it have a horizontal or end behavior asymptote? Where is it?
Negative.
Good. No holes. So this is it. What do you think? Did you sketch something that looked like that? And then something that looked like that. You okay?
Find that second curve, do we just plug numbers in?
Well, you can, or you can understand that because these are asymptotes, you either have to look like this, or you have to look like this. And you can't look like that, so you must look like this. But yes, you can always plot this. Always plot it. Okay, so the 1, 9, 10 homework due on Tuesday, and we will start working on drafting some that have slant asymptotes next time.